Hi everyone, welcome to the next tutorial, Mesh Swap Blueprint for Archviz. We have one constraint in using the Mesh Swap Blueprint in UE4. The thing is, inside the blueprint, we need to keep our static mesh as movable. And it may not work correctly in static lighting or light baking concept. But still, we can use this for any dynamic lighting scenario or in UE5 projects. Let's jump in and start the session. I'm splitting the tutorial into two parts, Concept 1 and Concept 2. The Concept 1 is a single mesh swapping concept. We are going to swap the single existing mesh with the new static mesh, and at any point of time we will have one mesh inside the blueprint. In concept 2, we are going to put multiple mesh within a blueprint with visibility control. I am a Revit user and good in family content creation, so I am going to create a blueprint same like the concept of nested families in Revit. We are going to load multiple mesh in the same blueprint and swap the mesh using the visibility control. I will explain the pros and cons of each concept, and you may adopt things as per your use case. I am in UE5 project with the new empty level, as it supports dynamic lighting, and I have few static mesh preloaded in the project for this tutorial. Before starting the blueprint creation, we need to finalize the trigger logic for our blueprint. I'm going to create a blueprint with static mesh, box collision volume, and user guide text. When the user enters the trigger volume, the trigger input needs to be enabled and the guide text will be visible to the user, like press F key. Then the user will press the input key to swap the mesh options in a looping concept. In the other way, when the user comes out from the trigger volume, the trigger input needs to be disabled along with the user guide text. Let's jump in and create the concept 1. Go to the content browser, right click, select blueprint class, then select actor and rename it as BP Mesh Swap 1. Open the blueprint and you will see the billboard. To get rid of the billboard, go to Components, add Scene Components, drag and drop the scene components to the root. Then add static mesh component. Rename it as existing mesh. Go to details, load any static mesh as our default mesh. Then add text and rename it as user text. Move the text in front of the static mesh so that the user can see the text. Go to details and edit the content as press F. We are going to use F as a trigger key. Add box collision and scale it as per the requirement. Now drag and drop the blueprint in the level and position it for our testing. Again, go to blueprint, viewport, select the box collision, go to details panel, create even begin overlap. and do the same for the even end overlap as well. We need to execute 3 logics to create this blueprint. Let us see. In the first logic, begin overlap. From there we need to enable the input, then enable the guide text visibility. And in the second logic, from the end overlap, we need to disable the input and disable the guide text visibility. Assign F as an input key, and we need to swap the existing mesh with the new mesh in a looping concept. Let's start one by one. Before creating the logic, first we need to disable the visibility of text in the blueprint. Let's create the first logic. Go to the event graph. On component begin overlap, enable input, then link get player controller. Then set visibility on for text. Let's go and test it. Player comes in and the text pops up. Good, and it works. Moving on to second logic. Go to event graph. On component end overlap, disable input and connect the player controller. Set the guide text visibility as off. Let's test this. Play. Player comes in and the guide text pops up and moving back, and it's turning off. Perfect. Moving on to the third logic. Go to the event graph, right click, press F, select the F key, then connect with multi-gate. We need looping, so turn on loop. Set the index as 0 and add 2 pins. Out 0. Add static mesh component. Then set static mesh. So you need to connect the existing mesh in the target and need to create new variable for new mesh. Go to my blueprint, add variable, rename it as mesh 1. Select the mesh 1, go to details, set the variable type as static mesh. And make it visible so that we can modify the input in the level. Let's duplicate the variable and rename it as mesh 2. Again duplicate, rename as 03. Again duplicate and rename as 04. Select the 2 nodes and duplicate it 3 times. And connect everything to the pins. Then connect variables to the nodes. Select the blueprint in the level. Go to the details panel and assign your mesh options. And make sure mesh 1 should match with the existing mesh inside the blueprint. Let's go and test it. Playing in the editor, and the player comes in, and the guide text pops up. Press F again to swap the next mesh. And moving back, input not working, perfect. And now the blueprint works fine. Good. Let's discuss about the pros and cons. And I'm not an expert, I'm still a learner, but this is purely my opinion. And for pros, we can modify the new static mesh selection in the level itself. We can modify the new static mesh selection in the level itself. For each instance, we can select the new static mesh. And the second is the single static mesh will be there in the blueprint at any point of time. So the poly count will be less compared to concept 2. And for the cons, the static mesh component, which means the existing mesh, cannot be modified in the level, and it needs to be done inside the blueprint. Second, we need to select the mesh 01, same as existing mesh, because we need to position our blueprint in the level. Third, we cannot reposition the origin of these swapping meshes as per our requirement, and it needs to be done in the source file. Say for example, if we don't have a source file and we cannot modify the rotation or a position based on our requirement. Let us modify the trigger logic and create a new version. Instead of looping concept, I'm going to assign separate keys for each swap option. Duplicate the blueprint and rename as BP Mesh Swap 1A. Open the blueprint, go to Event Graph and go to the Logic 3. Disconnect the multi-gate and the input key. Right click and select the input keys 1, 2, 3 and 4. Just connect each input keys with each swap option. That's it. Let's go and test it. Play. Player comes in. Press 1, 2, 3 and 4. Works fine. Like the same way, we can modify the trigger logic as per your requirement. You can even link it with widget blueprints using custom event. Hope this concept is clear to you. Let's move on to the concept 2. First, why we need the concept 2 and why can't we fine tune the concept 1 as per our requirement. Let's see the problem statement. Here we are dealing with two variable types. One is the static mesh, second is the static mesh component. Static mesh component is usually added from the component tab inside blueprint in viewport, and that the component cannot be swapped in its instance, like we cannot make it visible in public. And static mesh can be made visible in public, but we cannot visualize that mesh preview in the level. For example, I want to swap a stone bench static mesh to wooden bench and steel bench. To do that, I need to add stone bench as static mesh component in the viewport, and I will position it in the level as per the requirement. Then I may swap it with wooden and steel bench in runtime during play. But I cannot visualize spawn static mesh in the level to ensure the position and the rotation of the new static mesh is matching with the stone bench, the old one. This is my requirement for concept 2. Number 1. I need to visualize all the blueprint static mesh in the level itself, so that I can ensure the placement and the rotation of each static mesh is correct or not. Number 2. If some of the static mesh position and the rotation is different, I need to modify the same as per my new requirement. Usually in Arch-Viz projects, we may need to reuse the previous project assets, and we cannot ensure the origin is in the correct position or not. Number 3, this is the additional requirement. I need to control the visibility, position and rotation of each static mesh in the instance itself. Why I need this functionality? By default, the new spawning mesh will appear in the same location of the first mesh. But what if I need each newly spawned mesh to be in the different locations as per my choice? Even if I want to scale particularly one mesh options from the blueprint, I can do that using this functionality. So I am considering these requirements to move forward. We'll move on to the concept 2 in the next video.